question here is quite a difficult question about ideal gases. So we're going to start by highlighting all the key information in the question that we have to use. So it's given us the atmospheric pressure. We're going to use that eventually. That's 1 times 10 to the 5 pascals. It's given us a temperature in degrees, which we have to convert into Kelvin at some point to use it in calculation, because we don't use degrees in calculation with ideal gases. It gives us the mass of the ball, or mass of air in the ball, sorry. It's also giving you the circumference of the ball. It's then asking you to talk about the law about football pressure. So the pressure says it should be that much, between this and this much, above atmospheric pressure. So we're going to find what the actual pressure of the ball is given all these conditions. We're going to subtract from it atmospheric pressure, and it should be a value in between 0.6 times 10 to the 5 and 1.1 times 10 to the 5. Let's do that then. So I've given a prompt here of which equation to use and some of the more difficult parts of this question in case you wanted to have a go. But we're rearranging for pressure here. So pressure, let me get rid of the highlighter. Pressure is equal to N, the number of moles, multiplied by the molar gas constant, multiplied by temperature all over volume. So let's write that down. nRT all over volume. How do we know the number of moles? Well, that's where we use this equation here, because it's given us a mass of 11.4, and we divide that by the molar mass that is also given us in the question, 29. Now you don't have to convert this into kilograms or kilograms per mole because they'll cancel each other out. When you put this in a calculator, you get a value of 0.393. So that's your value of the number of moles. Capital R stands for molar gas constant, which is given to you in an exam. It's 8.31. So I just put that here. And like I mentioned before, the temperature has to be in Kelvin before you use it in calculation. So we take this value of 17 degrees and we add 273 onto it, which gives you a value of 290. And we divide all of that by the volume of the ball. As you can imagine, a ball is spherical, so the volume is 4 over 3 pi r cubed. But where do we get the radius from? All it's given us is the circumference. We know the circumference is like pi times diameter, but because diameter is like 2 times as big as the radius, we can just say it's 2 pi r, and that's equal to 690 millimeters. Here we're going to convert into meters, so 690 times 10 to the minus 3. Dividing both sides by 2 pi, we get the actual radius of the ball, which in a calculator will give you a value of 0.11. Now when we find the volume of the ball, we can put into our calculator 4 over 3 multiplied by pi, multiplied by that radius that you just found, 0.11 all cubed. Now putting all of this into the calculator will get you a value of 1.7 times 10 to the 5. So that's the actual pressure inside the ball. Now we go back to what the question asks. We're deducing if this satisfies the law of football about the pressure. The law of football says that the pressure should be between this and this much above atmospheric. It's told us atmospheric pressure, so let's start by taking away atmospheric pressure from it. And that will give you a value of 0.7 times 10 to the 5 pascals, which is in between 0.6 times 10 to the 5 and 1.1 times 10 to the 5. So that means it does satisfy the law of football about pressure. And yeah, that's pretty much everything you need to know for this question. A very difficult question. If you have any questions with it, just let me know in the comments down below. Otherwise, please like the video, subscribe, and yeah, I've linked my email in the description in case you want to hit me up for tuition inquiries. Thanks for watching.